Hello everyone, my name is Kan. Welcome back to my video. In this video, I will be discussing the nitrogen element, which is in the second chapter of the 11th grade curriculum. We will focus on three main substances containing nitrogen, namely nitrogen gas, ammonia, and nitric acid. So let's begin. I want to begin by showing you this. This is called the periodic table, as you've learned last year, right? Let's focus on the nitrogen element, abbreviated as the letter N. You can see that the nitrogen element is located in the second period in a group 5A, meaning that the nitrogen atom has 2 electron shells with 5 electrons in its outermost shell. The atomic number of nitrogen is 7, by which you can easily write down the electron configuration of this atom. On your right is the illustration of a nitrogen atom, and you can clearly see that there are 5 electrons in the second shell, which means it needs 3 more electrons to reach the stable configuration of the inert gas neon. Therefore, in nature, the nitrogen atom does not exist as an individual particle, but as a diatomic molecule called nitrogen gas. You may be asking where you can find nitrogen gas in nature. Actually, nitrogen gas is in the air that you breathe every moment. Besides nitrogen, the air also contains oxygen gas with the approximate proportion of 20%, and of course, nitrogen makes up the rest, 80%. As we lower the temperature to minus 196 degrees Celsius, nitrogen gas turns to liquid. In practice, people often use liquid nitrogen to make smoke in parties or to preserve biological samples like blood or tissues. As you can see in the video, they are pouring liquid nitrogen to make ice cream. Let's return to the structure of the nitrogen molecule. The two nitrogen atoms are connected with each other by the triple bond. This triple bond is so stable and so strong that in normal conditions, nitrogen gas is inert, which means that it does not react with most substances like oxygen, hydrogen, or magnesium, except lithium. Lithium can react with nitrogen gas at normal temperature to form lithium nitride. Nevertheless, things are gonna be different in harsh conditions. At elevated temperatures or under high pressure, some reactions can occur. Let's say this one. Nitrogen and oxygen gas can combine to form nitrogen monoxide when we raise the temperature to 3000 degrees Celsius or when there is a lightning strike. This reaction does occur in the rain, followed by some other reactions to finally yield nitrate salt. This salt will fall with the rain and then be absorbed in the soil. This process is called nitrogen fixation. Plants require nitrogen to grow properly, but nitrogen gas in the air is so stable that plants are incapable of using it. Nitrogen fixation is a process helping to change the stable nitrogen gas to usable nitrate salt, which is meaningful for the growth of plants on Earth. Another example is the reaction of nitrogen and hydrogen gas at high temperatures and under high pressure to result in ammonia. This reaction is of great importance due to various uses of ammonia in industry. A large amount of ammonia is used to produce fertilizers and nitric acid, which are crucial chemicals in agriculture and industry. Let's dig deeper into ammonia properties. In normal conditions, ammonia is a gas smelling like aged urine or fermented urine. This phenomenon is caused by the existence of a substance called urea, which decomposes into ammonia when urine is exposed to bacteria. If we dissolve ammonia in water, it reacts with a water molecule to form an ammonium ion and hydroxide ion. Because hydroxide ion is yielded, ammonia is said to have basic property. We can justify the basic property of ammonia by these two following reactions. Firstly, ammonia can react with hydrogen chloride to yield ammonium chloride, which is a salt. This equation can explain what we observe when we bring a bottle of ammonia solution and a bottle of a hydrochloric acid solution near to each other. It can be clearly seen that above the two bottles is white smoke, which is ammonium chloride. Another evidence of this property is the reaction between ammonia solution and iron 3 chloride to form iron 3 hydroxide, a reddish-brown precipitation. Let's consider another reaction. In this reaction, the oxidation number of nitrogen is increased from -3 in ammonia to +2 in nitrogen monoxide, while that of oxygen is decreased from 0 to -2. As you've learned, in this reaction, ammonia is called a reductant because it reduces oxygen gas, which is an oxidant. Therefore, besides basic property, ammonia also has reducing property, and it is a relatively strong reductant. This reaction is important in industry because it occurs in the first step of the Ostwald process of creating nitric acid. In the second step, nitrogen monoxide continues to form nitrogen dioxide, and in the final step, nitric acid is obtained. Nitric acid is one of the most important chemicals in the world. The market share of this chemical in 2016 shows that more than 80% of the nitric acid amount is used to produce fertilizer, which is one of the key factors to the success of agriculture. When dissolved in water, nitric acid can dissociate completely into hydrogen ions and nitrate ions. Of course, nitrogen ion plays a role in acidic property of nitric acid solution. But what makes nitric acid different from other acids is its oxidizing property. You can see that the oxidation state of +5 is the highest of the nitrogen element. Therefore, nitric acid is an exceptionally strong oxidant. Now we will focus more on this property. Let's see what will happen when we put a copper coin into a tube containing concentrated nitric acid solution. You can see that the solution is turning green with a reddish-brown gas releasing from it. This phenomenon is not observed when we replace nitric acid with hydrochloric acid, isn't it? The products of this reaction are copper nitrate solution, which is blue color, and reddish-brown nitrogen dioxide gas. This gas can partially dissolve in the solution, along with the blue color of copper 2 nitrate solution, resulting in the green color that you've seen in the video. In this reaction, copper is oxidized and nitric acid is reduced to nitrogen dioxide with the oxidation number of +4. As a general principle, when a reductant, which is at a low oxidation state, reacts with nitric acid, a variety of reduction products is obtained. The first one is nitrogen dioxide, as in the above example. Sometimes we will observe the formation of these following colorless gases: nitric oxide, nitrous oxide, and nitrogen. Nitric oxide can easily combine with the oxygen in the air to yield nitrogen dioxide, so it turns rapidly to reddish brown color when exposed to air. The final reduction product is ammonium ion, the only situation where we do not observe any gases. You might be asking what product would be obtained in each reaction, and the answer for this is that it depends on the strength of the reductant and the concentration of the nitric acid solution. Let's look at some other examples. Ferrous oxide is a reductant because the oxidation state of iron is +2, which is lower than its highest state. While ferrous oxide is oxidized, nitric acid is reduced to form nitric oxide. Phosphorus is also oxidized to phosphoric acid when reacting with nitric acid. The last example, in which iron 3 hydroxide is put into the nitric solution, is totally different. The oxidation number of +3 is the highest state of ion element. Therefore, nitric acid cannot behave as an oxidant in this situation, but only a normal acid. In conclusion, nitric acid is a strong oxidant, but only behaves its oxidizing property in reaction with a reductant. Okay, that's the end of this lesson. If you like this video, why don't you put a thumbs up and hit the subscribe button. Bye bye and see you in my next video.